Now, this is where we left off yesterday. Take a look. I had given you this chart, but I hadn't filled it in. Let's fill this chart in with the terms, what we're calling those things that you already know how to name. You learned how to name them, but you don't know what they're called. Some of the other terms we already got, like saturated versus unsaturated, hydrocarbons, other things we're going to get throughout the first chapter. They're just terms, all right? You got the hard stuff down, all right? You know how to name these, or at least you know how to name most of the major rules for this. All right, so let's talk about some of these things. When you see something called an alkane, what do you think is going to be the suffix for an alkane?
Ane.
And you were drawing these. You were naming these things that had alkanes. What do they all have? What was their major structural feature they had? They all had single bonds. All right. Now, here comes a neat little thing I do every year, too. I do it not just now, but many times throughout the year. Instead of giving you a formula, I try to have you guys figure it out. I do it with the Gibbs free energy. I do it with delta H. I do it with a number of formulas throughout the year. And I want to do it for this one, because this is a very typical type of question on an SAT test. All right? What's the next, like, they'll have 2, 7, 13, 28. What's the next number in the series? You know those kind of questions on the SATs? See if you can, I've just made up those numbers, by the way. Don't try to figure out some sequence. Let's take some alkanes, the simplest to some larger ones, and see if you can't figure out a general formula for any alkane such that if I told you you had C20, you could tell me how many hydrogens were in it. Okay? Watch. Let's take an easy one. Don't write any of these down. Okay? The simplest alkane, I think you'd all agree, would be CH4, methane, right? Looks like this. Right? That'd be the simplest one, methane. All right. What's the next one up? Ethane. What's the formula for ethane? C2, H1, 2, 3, 4, 5, 6, right? Right? What about propane? C3, H what? 8. So you getting the pattern? I bet you if I told you C20, you could already tell me the answer. What's it going to be? 25? How many H's would it be? 22. 42. Okay? All right. Well, there are already some mistakes there. But now my question is, can you give me a general formula for that? In terms of N, Cn, what must H be? So tell me what to write. H what?
N squared.
Not N squared.
N times 2N.
2N.
Minus plus 2.
Plus 2, exactly. And that's what you would use. That's a general formula. And it's nice to be able to come up with that backwards. If you can figure that kind of stuff out, you're thinking about it, you understand it. And then if I gave you a larger one, this would have to be, what, 42. Also, working backwards, if I gave you a large formula, like this one, you should be able to tell me that's an alkane. I can recognize that from the formula, because it's of the format CnH2n plus 2. All right, good enough. How about alkenes? What do you have for the suffix of an alkene? Ene. All right, and of course, the alkenes have what particular structural feature?
Double bond.
Double bonds. Was anybody absent yesterday, by the way? Nobody? Okay. All right.
What are you videoing? And
by the way, I have your test graded, and as I told you, I expected, most of the grades were, not everybody, but most grades were better than the previous one. In the other class, I think even in this class, I had perfect scores. But a lot of it's out of 40, a lot of high 30s out of 40, which is good. Now, can you tell me what the formula would be for this? Let's take a look. What's the smallest alkene I could have? Methane? Can I have methane? No, why not? Because I have to have at least, bare minimum, 2 carbons that have a double bond, right? You're not drawing this, just watch. All right. Fill up, I can't just draw like you might have done on the test, extra H's around there, right? Some people did that. Could only have a total of 4 bonds around any given carbon. So that's what this guy looks like, C2H4, 1, 2, 3, 4. How about this guy? What's he going to be? C3 what? H6, got it? We're not doing the next one. What's the next one going to be? C4 what? Everybody see it?
CN plus H2N.
CN, H what?
2N.
Just 2N, exactly. CN, H2N. Right, good point. Josh is thinking ahead. If I have multiple double bonds, that won't apply. That's a good point. All right, but if I only have one double bond, that would apply. All right, and alkynes, I bet you can figure him out. Well, matter of fact, let's just use, instead of drawing the alkynes out, let's just use a little common sense. We know the suffix is going to be Y and E. That's not a surprise. And we know they have triple bonds. Using a little common sense, what do you think, looking back at these, this guy's going to be CNH what? I've got a triple instead of a double bond then. 2N minus 2. So you have 2N plus 2, 2N, 2N minus 2. Okay? And you'll see that it actually works if I do the formula. All right? Here's the smallest alkyne I can have. Here's the next smallest. All right, this would be C2H2, C3H1, 2, 3, 4. Next will be C4H6. See how this works, by the way, if you're, those of you, I'm sure everybody understands a little bit of algebra here. N, 2N plus 2. 2 times 2 is 4, plus 2 would be, for an alkane, would be 2 times 2 is 4, plus 2 is 6. This is an alkyne. 2 times 2 is 4, minus 2 is 2. 2 times 3 is 6, minus 2 is 4. 2 times 4 is 8, minus 2 is 6. That's how it works for all of these, but using that for how to use a formula. All right, good enough. Now, alkyl groups, you may have thought, well, I don't have that. That wasn't on my rules. It's okay. I was very generous on the rules. If you basically did what I asked you to do, you got full credit on the rules. So, mostly got 10s out of 10 on the rules, and like I said, the grades on the thing, even though you had to figure it out on your own, the grades on the test were pretty good too. But you probably didn't have a group called alkyl groups. But where have you seen the YL ending? Well, you saw it when it was somebody coming off of a longer chain. Okay, so if you had a longer chain like this, and then you got two guys coming off here, maybe one guy coming off of there. They all have their correct number of H's around them. But this is an alkyl group. This is an alkyl group. It's just basically a group of carbons coming off a longer chain. Okay? You didn't really call it that. But you did notice you did have a YL ending for those guys. All right? For example, what's the name of this group? Methyl. And what's the name of this group? Ethyl. And then propyl. You could have gotten up, as high as you want to. All right. So, can you figure this guy out? Well, first of all, the structural feature of this guy is that he is I'll call him a substitution group. And he's something else, another chain of carbons coming, or some amount of carbons coming off a longer chain. There are many things we're going to put onto that chain, guys. You've already seen me put some on there. You've seen me put chlorines on there, and fluorines on there, and bromines on there. We're going to put other things on there as well, oxygens, nitrogens, and we're going to learn how to name all of them. We're going to learn how to name every single one of those guys. And we're going to probably call all of them pretty much substitutions. That's what I will call it. Things that were added to the longer chain. All right? Can you give me the formula for this guy in terms of N? CNH what? What do you think? Again, using a little common sense. See if you can figure this one out. Let's take a look again. Oops, I keep doing that. I keep hitting the wrong one. If I've got a group coming off of another group, like this. Let's just take this simple methyl group coming off of here. He's kind of like methyl, kind of sounds like methane. What's going to be different between this and actual methane? What's he going to have one less of? He's going to have one less hydrogen because he has to attach to the chain somewhere, right? So what do you think? 2N not plus 2. We just said he's going to have one less, plus 1. CN, 2N, plus 1. Good. Very good. All right, now the last one I want to show you, as you can see, is something we did not see. You did not see cycle of alkanes. All right? But basically, these guys are ring structures. And I am going to talk about them more tomorrow than today. Let me show you one here. All right? For example, if I have this compound right here. P is just what? Who can tell me what compound that is? W! Get it? Let's say W. It's tungsten. Why did I say tungsten? Is he up there? No, he's not. W, yeah, formula, or the symbol for tungsten. What is this guy? Come on. Pentane. Everybody agree it's pentane? Right? 5 carbons, right? All hydrogens around it. Good. All right. Here is, I take off one of these hydrogens, I take off another hydrogen, and I connect them into a ring, spin them around and connect them into a ring, and now I've got, ta-da, oops, not quite ta-da, to do, much to do about nothing. That's not correct either. Now I've got what? I've got pentane still, but it's called cyclopentane. And I lost a couple of hydrogens in order to break a bond to be able to get these guys to add together. So this guy's called cyclopentane. So I don't actually have a new suffix. What do I have a new thing? I have a new prefix. Cyclo for a prefix. If I have a ring structure. Okay? All right. So let's talk about cycloalkanes a little bit. By the way, one neat little thing about cycloalkanes. What do they have the same formula as? God bless you. What's that? Alkenes. Because notice I removed 2 of these in order to be able to make that. They'll have the exact same formula as alkenes. So I'd have to be specific about that on the test of which one I was talking about. All right? Okay. Now, you have all that copy, because I'm going to erase that to give myself a little bit more room here. That good? Okay. Let's talk about cycloalkanes just for a little bit. We're actually going to come back to them a little bit more tomorrow. A lot more tomorrow, actually, when we talk about the conformational isomers. But for today, let's just get some basic stuff about cycloalkanes down. The N carbon atoms of an alkane chain are joined to form a ring. See, a regular alkane chain, a straight chain molecule, it's not hooked together. Okay, we call that an aliphatic carbon chain. All right, aliphatic organic compound, hydrocarbon. They're different from ring structures, which are connected and form a ring with the carbons. And that can happen too. You see, by the way, if you haven't noticed already, we kind of get lost in the weeds sometimes. But let's go back to the first day I started talking about organic. There are more compounds of carbon than there are of all other compounds combined. You can see that just taking 10 carbons and a mess of hydrogens, I can make all kinds of compounds from that, okay? With double bonds, with triple bonds, with ring structures. I mean, I can make a ton of carbon compounds with just those guys. I can't do that with salt. Sodium and chlorine get together and they make NaCl. They don't make chains of them. I mean, it grows into a crystal, but it's not the same thing. All right, let's do some examples of these guys. What will be, and you should all have that written, but I'm going to get rid of it so I have more room here. You have room down there for a couple of examples, right? And what do you have here? Name or formula? Name. Okay, so name is like on the left, and formula is on the right, right? What is on the right? Structure, whatever. Structure. Structure is on the right. All right, so you fill these in. Let's take the simplest. I asked you what the simplest alkene would be, and you all agreed it was ethene. Couldn't be methane. What's the simplest cycloalkane I could have?
Cyclomethane.
Cyclomethane. Okay, so put all those into a ring. Put that one carbon into a ring. Cycloethane. Can I put him into a ring?
Butane. Come on.
You had to skip the one that was right, Emily.
Well, who's the one that's right?
Oh,
Propane.
Propane. Oh.
Propane. It's what the pros feel when they get hurt. Propane.
I don't even know what propane is.
Yeah, that's right. It's what the pros feel. Propane. It's not pro healing. It's amateur pain. That's what I feel. That's what you guys feel. Is amateur pain. All right, that is not cycloamateur pain. That is cyclopropane. Cyclopropane. Got it? I could have cyclobutane, I could have cyclopentane, but I'm going to skip ahead to a guy that we're going to see a lot of. And you actually do see a lot of him in organic chemistry. And I'm going to draw an example of a guy who's a cyclohexane, but I'm going to put other stuff on him. Like, you know, I could put fluorines and chlorines and methyl groups and stuff on a longer chain of carbons. Well, I could do it on a ring structure too, and I will show you that with my second example. Does everybody have that guy copied? Got that guy? Okay. Let's do another example. This is the only other example I'm going to do today, but we are going to come back to these guys again in the future. All right? How about this? How about I draw this guy for you over here, and you so on the right-hand side, and you give me the name. And there will be mistakes. Okay? I want to put these in the same spots. Okay? Can you draw that, please? Let's see if we can name it. Now, coming off of this carbon is an F. That's an F there. Coming off of this carbon is a Cl. And off of this one is a CH3 or a methyl group. But there are 6 in a ring. See the 6 in the ring? And at the end of every one of these will be an H, as you all already know. Draw that guy as I have him drawn, because it will be important that we're going to have them in the same spots. Because we're going to try to name him correctly. Okay, y'all have them drawn. What's the last word I'm going to write next to this guy? The last thing I'm going to write. I have all these other guys I'm going to name some way. The last thing I'm going to write is going to be not just hexane, but cyclohexane. So the last thing you're going to write here is cyclohexane. My question to you is, how will you name all that other stuff and number it correctly before it? Why don't you try it? I'll give you a couple of seconds to try it. Same logic applies to your straight chain carbons, your aliphatic carbons. Same logic applies. See if you can name it. Go ahead. Write something down. It's good to make mistakes, as you're going to see in the next part of this class. I'm going to have you make a lot of mistakes.
Because you like watching us fail.
Because I like making fun of you, actually. You should have seen it. I made fun of Nikki big time today.
Nikki.
Did you record it?
Yeah.
Can we watch it?
Nikki, no.
Don't worry about it. It's going to be Emily today. And it won't have to ask Emily who.
Well, because everyone already knows you're a mess up.
Mm-hmm.
So it's okay.
Mm-hmm. All right. You guys got an answer for this?
Yeah.
Well, let's see what you think. I've got to call this guy, fluoro, he's chloro, and he's a methyl. But what way do I have to number them? That's the question. Well, what's the rule for aliphatic carbons? What's that you've been doing? What's the rule?
Start from the lowest number of chains.
Okay, lowest number for the substitutions that are on there, right? Okay. How can I get the lowest number out of these guys?
Start down at the bottom one.
Start where? Here? Here?
No.
Here?
The bottom one.
That's the bottom.
That's the bottom.
There is no bottom, people. There is no bottom. There's no top. These are all three-dimensional structures. I can rotate them any way I want to. So to give me the lowest possible numbers, which carbon should I start with? Not with the Cl.
No, the one to the right of the Cl.
No. Fluorine. If I start and number them here, let's watch what happens. Okay? If he's number 1 and I go this way around the ring, he's number 2, 3, and he's number 4. So my numbers will be 1 fluoro, 2 chloro, and 4 methyl. So if I started here as the number 1 carbon, that's terrible. I would have this is 1, it'd be 2, 3, 6. That's a lot higher than 1, 2, 4. You might say, well, can we start here as the number 1 carbon? I can, but it won't be the lowest possible numbers. What would the numbers be if I started here? 1, 3, 4. See it? You say, well, how come I don't go around? See, you're thinking two-dimensionally and you're thinking very rigid. There is no top. There is no bottom. All right? There's no right and left. There's no clockwise and counterclockwise. You start from wherever is most convenient for the lowest possible number, and you go whichever way gives you the lowest possible numbers. You don't have to go that way. You don't have to go this way. You go whatever gives you the lowest. So you see why this is going to be. And if I were to put them in alphabetical order, I would be this. It would be 2 chloro, 1 fluoro, 4-methyl cyclohexane. Oh, and by the way, this class in particular, Emily in particular, but not the only person.
Oh, God.
Multiple people in this class. I did not take off for it on this test, but I absolutely will in the future. You have to put down the dashes or commas or wherever they go, whatever goes where. You have to put those things down. So 2-chloro, you got to put those in
I
there.
didn't do that.
No, you didn't.
How do you know that?
Because I graded the test.
But, like,
Will
why
we
did
get
you
the test
stop
back
me?
today?
I'm just talking because I just graded it 5 minutes ago. What?
Will we get the test back today?
Yeah, I just finished grading your class last period. That's why I stuck in my mind. All right. So, y'all have that written down as the correct answer? All right, good. Now, look. What time is this over?
My hands smell like good, but it's making my head hurt.
My hands smell good, but it's making my head hurt.
Because it's like
Quote
too
from Emily.
overpowering. The air conditioner.